Good morning. How are you guys out there today? I don't know if anybody's watching, but hello. This is Calculus from Sauk Rapids Rice High School, Southwest 211. And today's topic is partial fractions. So the idea is this. We have some type of situation in which we have a function on top and we have a function over on the bottom. So we have called that a rational function. And this will only work if you can factor, all right? And if you take a look, I have two fractions, and here's the idea behind it, is I simply have the fraction 1 over x minus 2 and negative 1 over x plus 3, and if we were to add these together, we would get a common denominator, which is the product of the denominator, correct? And so what I did is I multiplied this first fraction by x plus 3 at the top and the bottom, and I multiplied this second fraction by x minus 2. Now when I multiplied the top by x minus 2, the numerator was a negative 1, so it changed signs. Does that make sense? And so when I add them together, the x's cancel out and are gone, and I'm left with 5. I'm left with this particular constant. Okay, so this rational expression came from here, all right? And normally when we see this, a couple of ways we approach it is we say, well, we have this x squared here. If I were to use natural log, if you remember, the derivative of natural log means the function goes on the bottom and its derivative goes on top. And the derivative of this would be 2x plus 1. So I can't use natural log in this form. Another thing I could take a look if it was to some other type of power, perhaps its derivative would be on top here. And that's not the case. So how do we approach this? Well, we're going to get functions that look like this, and our goal is to break them down so they look like this. Because now I can take the antiderivative of this, and I would have natural log in both of these, because the derivative of this would be 1 and the derivative of this would be 1. So I could look at it as two separate natural logs. Is that kind of making sense? All right. Then, so I call this, going from here to this direction, I call that decomposition. In other words, what were the fractions that we started out with that created this? And this is the method we're going to look at. The first thing, it tells you that if the degree on top is greater than the degree on the bottom, you want it to divide it out because it's an improper fraction. So you want to do the long division, and then we'll work with the remaining fraction that you have. If you don't have that, here are your steps. First of all, you want to factor the denominator completely. That's your first step. And you want to factor until you can't factor any longer. And again, we'll do examples of this. Secondly, in the denominator, for each factor in the form, okay, so what I'm saying is if I have something like this, 3 over x plus 1 squared. This is called a linear factor. And I'm going to write this in this form. I'm going to look at this, I'm going to break it up into two fractions, and it's going to make more sense in a bit, as x plus 1 plus another number, they call it a2 here, I call it b, x plus 1 squared. If this was cubed, you would go another one, c over x plus 1 cubed. So you have all the powers leading from 1 up to your greatest power. Lastly, if you factor and you get a quadratic that you no longer factor, what you're going to have up here is some type of linear form. All right, again, so if this is non-factorable, you need to have something that's in the form, I call it cx plus d, and I'll do an example of that. All right, so look, I'm going to flip to the next page. And here's my first one. My first example. And so on the side, I do this. 2 over 9x squared minus 1 can be factored to 2 over 3x plus 1 times 3x minus 1, the conjugates. So I can say that this rational expression, this way, there, is that better? 3x plus 1 times 3x minus 1, that came from two separate fractions. I don't know a, I'm going to figure out a, but one of the denominators was 3x plus 1, and the other denominator was 3x minus 1. And this fraction, this rational expression, is the result of this. How did that happen? Well, it happened that a over 3x plus 1 plus b over 3x minus 1, we multiplied both sides. One side got multiplied by 3x plus 1, and the other side got multiplied, oops, this should be a minus 1. I said minus 1, I wrote plus 1. And the other one got multiplied by 3x plus 1 to get this common denominator of 3x plus 1, 3x minus 1. So I multiplied a by 3x minus 1 and the denominator by 3x minus 1. And on this fraction, I multiplied the numerator by 3x plus 1 and the bottom by 3x plus 1, and then combined them. So they look like this. So that means this numerator, which has the same denominator, must be equal to this numerator. So over here I'm going to write down 2 equals a times 3x minus 1 plus b times 3x plus 1. Now I'm going to solve for a and b. And this is true for any x. Any x that I choose, that's going to be true. Well, the x's that I'm going to choose are the ones that create 0 in these quantities. So I'm going to say, all right, what is a or b if x equals a third? If x equals a third, I'm going to have 2 equals. Now, if I put a third in here, I get 0, correct? Now, the reason I can do this is because I'm not talking about the denominator. If I put a third into here, I'd have issues, correct? But since I'm only talking about the numerator, I can ignore the denominator. So if I put a third in here, what would this numerator be? Well, 2 would equal, this would be gone, and I would have b times, well, 3 times a third is 1, and 1 plus 1 is 2. That means b has to equal 1. Then I'm going to choose a negative 1/3. Why am I choosing a negative 1/3? Because that makes this 0. And I'm going to get 2 equals. Now if I put a negative 1/3 in here, I'm going to have 3 times a negative 1/3 minus 1. And so I'm going to have a times a negative 2. That means a equals a negative 1. So what I am saying is that a negative 1 over 3x plus 1 plus 1 over 3x minus 1 should give me this as my answer. And so I'm going to check. Well, I'm going to get a negative 3x plus 1 plus 3x plus 1 over the quantity 3x minus 1 times 3x plus 1. Do you see how I got those? I just multiplied this fraction top and bottom by 3x minus 1 and this fraction top and bottom by 3x plus 1. Well, what happens here? Those are gone, and I'm left with 2 over 3x minus 1 times 3x plus 1. So this is equivalent to this. All right? So now I'm going to rewrite this integral. I can say that this integral is the same as a negative 1 over 3x plus 1 dx plus the integral of 1 over 3x minus 1 dx.
So where do you get the negative 1 from?
That's what I determined A to be a negative 1 right here. And so I came up here and stuck it into A.
Okay.
All right? This right here, Carter,
Yeah.
was me just checking out that if I put negative 1 for A and 1 for B, that when I multiplied it out, would get this.
Okay.
In other words, these two fractions created that fraction. Does that answer that?
Yep.
All right. So now I'm going to bring out my negative here. And I got 1 over 3x plus 1 dx. If I want to figure out the antiderivative of this, does everyone see why I need to multiply the top by 3? Because I need to have the derivative of this denominator in the numerator. So right here I have to have 1/3. So now I have a negative 1/3. Plus, I'm going to multiply this one, the top, by 3. That means this has to have 1/3. So this gives me a negative 1/3 natural log of 3x plus 1 plus 1/3 natural log of 3x minus 1 plus c, which means I could write this as the natural log of the cube root of 3x minus 1 over 3x plus 1 plus c. Is that too big of a jump? Really what I'm doing is I'm taking this minus that, correct? So I'm taking this log minus that log, which means I have division. 3x minus 1 divided by 3x plus 1. My exponent is 1/3, so I could have written this to the 1/3 power, but I chose to write the cube root.
So if we left it in the form above it, would we still get the points, or do we have to write it?
No, the reason I'm giving you this form, you could leave it like this, okay? I'm giving you this form because there are partial fraction questions on the, and they're usually the multiple choice, and they usually give it to you in that form, okay? Do you have to? No, okay? All right, so I'm going to are we okay with number 1? All right, so number 2, again, my first step is to take 3 minus x, and I've got 3x squared minus 2x minus 1, and I'm going to factor the denominator. If I can't factor the denominator, I am not using partial fractions. the denominator must be factorable. And so I'm going to factor this. The only thing this can be is 3x, and the only thing this can be is x. And I either got to have a positive 1 or a negative 1. Can you see that this is going to be a negative 1 and this is going to be a plus 1? Okay? So that means 3 minus x over 3x plus 1, x minus 1 is going to equal something over 3x plus 1 plus something over x minus 1. Now, if I would have 3 factors, I'd have 3 fractions. We are going to look at that. So that means a times x minus 1 plus b times 3x plus 1. Okay, do you see where I get that? Is going to equal 3x, or 3 minus x. In other words, when I'm making a few jumps here. I'm ignoring the denominator, right? I'm just going right to the numerator. When I multiply a by x minus 1 and b by 3x plus 1, the denominators are going to be the same. And I'm only interested in looking what the denominator is, so I came up with this equation. All right? Now, I'm going to choose an x. Yep. What x do you think I'll choose? No. I could choose 3, okay, but I'm going to choose 1. Kayleen says I should choose 1. Kayleen, why do you think I should choose 1? Yeah, because this one will be 0, won't it? And I'll be left solving just b. So I'm going to have b times 4 equals 2. So I know that b equals a half. Are we all right on that? Okay. So now, what do you suppose I'm going to choose for my next x?
-1/3.
Yes, a -1/3. And Carter, how did you get that?
To get the b side to equal 0.
Yeah, I want the b side to be equal 0, and if it's a -1/3, then, so what I'm going to have here, if I plug in a -1/3 in here, a times a -4/3 equals, well, I'm going to have 3 minus a -1/3. I'm going to have 3 plus a third. That's 3 1/3, which is 10/3. Which means a is equal to a -5/2. You see how I get that? I multiply by the reciprocal. I get 10 over a -4, which is a -5/2. All right. So now I'm going to show you my check in case I made a mistake. So my check looks like this. I have a -5/2 over 3x plus 1, plus 1/2 over x minus 1, which gives me a -5 over 2 times 3x plus 1 plus 1 over 2 times x minus 1. Are we all right with that? Which gives me a negative 5 times x minus 1 plus 3x plus 1 all over 2 times 3x plus 1 times x minus 1, which gives me a negative 5x plus 5 plus 3x plus 1 over this. And this will simplify to a negative 2x plus 6 over 2 times 3x plus 1 times x minus 1. Again, this is just my check, and I'm going to factor out a 2, and I'll get a negative x plus 3, and down here I have a 2, and I get 3x plus 1 times x minus 1. Those simplify, and sure enough, that's what I had, correct? Does that work? Okay? So now, this is how I solve it. This is going to become the integral. A negative 5 halves times 1 over 3x plus 1 dx plus 1/2 times the integral of 1 over x minus 1 dx. I'll fix that. So up here I need a denominator of 3, a numerator of 3. So I'm going to multiply by a third. So I get negative 5/6 natural log of 3x plus 1. Here the denominator, the derivative of x minus 1 is 1, so I have plus 1/2 natural log of x minus 1 plus c. I'm done. So the work really comes into the partial fractions, doesn't it? Once you integrate, you go, well, that's nice, it's natural log. Is it natural log most of the time? Yeah. There is a little bit of an exception, and I'll show you where that is. Okay? All right. Number 3. So I'm going to take 5x minus 2 over x minus 2 squared, and this is going to be a over x minus 2 plus b over x minus 2 squared. That's how you're going to have to deal with when you have multiple linear expressions. That means 5x minus 2 is going to equal a times x minus 2 plus b. Since this already has this as the denominator, I'm going to be multiplying this by x minus 2 and this by x minus 2. Now, what do you suppose I'm going to start out x being? 2, right? Would you agree? So I'm going to 2, and it's going to be 8 is equal to b. Now, I got to figure out a. I can let x be anything I want. I said that from the beginning. The reason I chose 2 in these other numbers is I got rid of one of the a's or b's, they became 0, but it can be anything I want. I already know b is 8. So what do you want me to choose for the next x? It doesn't matter. 3. So if I choose 3, okay, if I choose 3, I'm going to have 5 times 3 minus 2, which is what? 13, correct? Is equal to a times 1 plus 8. Because that's what b is. That means, well, I should write down that we chose 3. That means a is equal to what? 5. All right? So now I'm going to integrate, and this is going to become 5 over 1 over x minus 2 dx plus 8 integrate 1 over x minus 2 squared dx. So here's my one exception. I think everybody's okay that this is 5 times the natural log of x minus 2. I'm not going to use natural log here, am I? This is really x minus 2 to the 2 power, correct? Right? And the derivative of x minus 2 is 1, so I don't have to worry about that, am I? I can simply reverse the power rule. In other words, I am taking the antiderivative of this, right? I'm going to add 1 to that, correct? What am I going to get? A negative 1, right?
Yep.
And then I'm going to multiply by a negative 1. So I'm going to get negative 8 over x minus 2. Is that too big of a jump? Can I expect that you guys do that in your head? Plus c. So that's the type of thing that can happen. Again, a not bad integral, but they're not always natural log. All right? Just 2 more, because I want to give you all the possibilities. Okay? So this one I have, I'm going to look at this. I'm going to put this to the side up here. Up here, I'm going to write it. So I have x cubed plus x squared minus x minus 1. And the reason I chose this one, does anyone remember how to factor that? I'm guessing no. Am I right? Okay. I'm going to put parentheses around these first 2. Maybe that'll help. What can I factor from there? An x squared, correct? So I get x squared. What do I have left in there? X plus 1. Can I factor something from this so I get an x plus 1? I'm going to factor a negative 1, and I'm going to get an x plus 1. Remember doing something like this? And so this is going to be x plus 1 times x squared minus 1. Would you agree? Which is the same as x plus 1 times x plus 1 times x minus 1. Because this is a difference of conjugates, difference of squares. If I multiply the conjugates, I get that. So this 8x over this is equal to a over x minus 1 plus b over x plus 1 plus c over x plus 1 squared. And I want to make sure everybody understands why there's 3 of them. Because this one squared, it's going to take 2. All right? So that means 8x, this numerator, is going to be a times x plus 1, the quantity squared. Because that's what I would have to multiply here. This one is going to be plus b times x plus 1, x minus 1. Does that make sense? Plus c times x minus 1. All right? Okay. X equals what? What do you want to start it to be? 1. Okay? Yeah, if I choose 1, then I'm going to get 8 is equal to a times what? If I put a 1 in here, what am I going to get? 4. What will I get here? A 0, correct? And I get a 0 here, don't I? So that means a is 2. What's the next number I'm going to choose x to be?
-1.
-1. That means -8 equals, well, this will be 0, this will be 0, and I'll have c times a -2. Would you agree with that? That means c is equal to 4. So what do you want the next one to figure out b? What do you want it to be? What would be a good choice? Yeah, let's choose 0. So I'm going to get 0 because 8 times 0 is 0 equals, and I know a is 2 times 1 plus b times, well, if I put 0 in here, I'll get 1. If I put 0 in here, I'll get a -1, so that must be a -1 plus c times a -1. Are we all right with that? What do we get? What's b equal to? I got b equal to a -2 also. Right? You would add these together, you'd get -2. B would equal -2. All right. So that means now my integral is going to become, what was a? 2 times 1 over x minus 1 dx plus b was a -2, integral of 1 over x plus 1 dx, and c was 4, so plus 4 integral 1 over x squared plus 1 squared dx. So I want you to make sure you look at those integrals and see where they came from. I find it easier if I take the numerator and write it out in the front and multiply, because I can look in here and say, all right, do I have the derivative of what I want here on top? Do I have the derivative of this on top? And the same all the way through. Does that make sense? So this is going to be 2 times what? natural log of x minus 1 minus 2 times the natural log of x plus 1. What will this be?
4/3.
Okay, it's a negative 2, correct? You gotta remember that. It's not a fraction. It would be negative 4, right? It becomes negative over what? X plus 1 to the first power, because a negative 2 plus 1 is a negative 1, and that's what you're going to get, plus c. And I'm assuming this class will never forget their plus c.
Hopefully.
Not too bad? What do you think? It's not bad, is it? Okay? So, x over 16x to the 4th minus 1 equals what? Well, let's take a look at 16x to the 4th minus 1. Usually on the side I factor that. What do you think that'll be? What squared?
X squared.
Something squared.
Oh, 2x.
4x squared plus 1 and 4x squared minus 1. Would everybody agree? All right, now, is it completely factorable? Have I factored everything? No, I can do this now too, can't I? So I'm going to get 4x squared plus 1 times what over here?
2x minus 1 and 2x plus 1.
Correct. Now, this is linear. This is linear. It's called a linear factor. Would you agree? Because this x has a degree of 1. This means this is going to have a as the numerator. This is going to have b as the numerator. This is quadratic. Because it's got a degree of 2. You have to have this. I've already used a and b, so I'm going to use cx plus d. You have to have this as your numerator. Notice these are constants. Think about this. If you take the derivative of these, you get a constant, right? This is a quadratic. If you take the derivative of that, you get a linear, don't you? That's the idea behind that. It decomposes. You know how you take polynomials, and when you take the derivative, they decompose eventually to 0? That's kind of what I'm doing here. All right? So this is going to become a over 2x minus 1 plus b over 2x plus 1. Now, do I have to have a over this factor? No. Do I have to have b over this factor? No. You could switch them, but I have to have cx plus d over this factor. Are we all right with that? So I'm going to have x equals, I'm going to create my numerator equation is what I call it. So I'm going to have a times 2x plus 1 times 4x squared plus 1. I'm going to have plus b times 2x minus 1 times 4x squared plus 1. And of course, I didn't give myself enough room. Plus, I'm going to have cxd plus d over 2x plus 1, 2x minus 1. I'll write that a little bit better. That's really icky. So I'll rewrite it. X equals a times 2x plus 1 times 4x squared plus 1 plus b times 2x minus 1, 4x squared plus 1 plus c x plus d times 2x plus 1, 2x minus 1. So what are we going to let x equal the first time?
One
1/2.
half.
That's exactly what I did. So if I let it be 1/2, I get 1/2 equals, well, 2 times 1/2 is 1. So I'm going to get a times 2. Would you agree? Times. If I put a 1/2 in here, I square it, and I get a 1/4. And 4 times a 4th is 1, and 1 plus 1 is 2. So I get another 2. So that means a is equal to what? 1/8. X equals what next? A negative 1/2. So that means a negative 1/2 equals, well, if I plug it in here, it's 0. So I can plug it in here, and I'll get b times a negative 2. And if I plug it in here, I get a positive 2. So what is b? One 1/8 also. All right. X equals what? What do you want to pick? What would be an easy number? Zero, I think, is a real nice number. So I get 0 equals, well, I'm going to have 1/8, because I know what a is, times 1 times 1. Would you agree? Plus 1/8 times a negative 1 times 1. Is that convenient?
Yes.
Yeah, because they're gone, aren't they? Right? Plus, well, if I put 0 in here, I'm going to get d times 1 times a negative 1. So that means 0 equals a negative d, correct? So what does d have to be? D has to be 0. All right, we got to figure out C. What do you want to choose for C? What would be the next nicest number? 1. So if I choose 1 in here, I'll get 1 equals 1/8 times 3 times 5 plus 1/8 times 1 times 5 plus C times 3 times 1. So I get 1 equals 15/8 plus 5/8 plus 3C. So I had 1 equals 20 over 8 plus 3c. This is 1 is equal to 5 halves, I think, isn't it? Plus 3c. Am I right on that? That 28 is 5 halves? What do I get over here? I think I get a negative 3 halves is equal to 3c. So c equals a negative 1/2. So this is what it's going to look like now. I have 1/8 integrating 1 over 2x minus 1 dx plus 1/8 integrating 1 over 2x plus 1 dx. Integrating. It's a negative 1/2 and down here I have 1 over, oh, excuse me, what do I have up there? I have 1/2 x, so I have x, don't I? Right? X over 4x squared plus 1 dx. Right? Don't I have 1/2 x? Right? Would you agree with that? All right. So what do I need on top here? A 2, correct? And so this will be a 1/2. So this is going to be 1/16 the what? Natural log of 2x minus 1. Plus, I'm going to need a 2 up here for the same reason, so I need a 1/2. So I get 1/16 of the natural log of 2x plus 1. What do I need here? I need an 8 here, don't I? Correct? So I'm going to multiply by 1/8. So it's going to be minus 1/16 what? Yeah, it's the natural log of what? 4x squared plus 1 plus c. Now my guess is you're going to see something like this. 2x minus 1, 2x plus 1 divided by 4x squared plus 1, all rate, I suppose I'll have brackets, to the 1/16 power plus c. My guess is that's how you would see something, or even they may multiply that on top. They have 4x squared minus 1 over 4x squared plus 1 raised to the 1/16 power. Don't you think that's how they'd write it? Okay. What do you think of this? I call this comfort math. I like it. I like it better than trig substitution. I think it's kind of interesting. I like fractions. So, I don't know. I hope the people out there that aren't here today, that are sitting there watching this, are going to watch it later, just have a fine appreciation for fractions. Okay. All right. We are done for the day. Have a pleasant afternoon.